Today we're going to look at naming ionic compounds that contain polyatomic ions. So we've written their formulas, so now we're going to look at how you would name some of these. Whenever there's a polyatomic ion, all you have to do is name it just like it is. So in this case, we'd name the first element just like it is. So this would be magnesium. And then this is a polyatomic ion nitrate, so that's all we have to do is put the term nitrate. Since it only has a specific charge, then we don't have to worry about Roman numerals on any of the negative parts of the name. And we always want to look at our positive part and make sure it's not one of those elements that needs a Roman numeral. In this case, magnesium is in column 2, so it always has a +2 charge. It does not need a Roman numeral. If we look at our second one, we again have magnesium. And this polyatomic ion, CO3, is the carbonate. So all you have to do is just write the term carbonate. And finally, for the last one, you have magnesium with a PO4. So this would be phosphate. So this compound is named magnesium phosphate. Now, if you do have an element like lead, for example, in this two examples, since it is not in the first two columns and it's not silver, cadmium, zinc, or aluminum, then you will have to put a Roman numeral to indicate the charge that the lead will have. So when we're naming this, we're going to just say lead. We know we need a Roman numeral, and then the OH is our hydroxide ion. Again, a polyatomic ion, just name it as it is. To figure out the charge of the lead, we just look at the charge of the hydroxide. Hydroxide is -1, but I have 4 of them, so that means that this whole half is -4, so that means this whole half needs to be +4. Since there's not a subscript here, then we simply use the 4 as our Roman numeral. If we're looking at the next one, again we have lead, so we know that it needs a Roman numeral. The NO3 is nitrate. Nitrate has a -1 charge, so the NO3 has a -1 charge, but I have 2 of them, so that's going to make this half a -2, so the lead's going to need to be a +2. And again, since there's no subscript here to divide that into, you simply use 2 as your Roman numeral. Our last example, you have nickel, and again, nickel's not in the first 2 columns, or cadmium, zinc, aluminum, or silver, so it does need a Roman numeral, so we'll just say nickel, Roman numeral, and then this is the arsenate ion. Arsenate ion has a -3 charge. I only have 1 of them, so that makes this half -3, that makes this half +3, so I would need a Roman numeral 3 here. Now these are some others to practice that are on the PowerPoint, so we'll go ahead and run through these real quick. Again, look at your first element. Since this is a single element, then we write it just like it is, so that would be copper. Since it's not in the first 2 columns, or silver, cadmium, zinc, or aluminum, it needs a Roman numeral. And then the SO4 is a polyatomic ion that's called sulfate. So to figure out what the charge of the copper is, we look for the charge of sulfate. Sulfate is -2. There's 1 of them, so this half is -2, meaning this half needs to be +2. So my Roman numeral here would need to be a 2. My second one, I have polyatomic ion at the beginning and at the end, so all I have to do on this one is just name both polyatomic ions. So my NH4 is ammonium, and then the OH is hydroxide, and that's it. Since both of these have a specific charge, then there's no need for Roman numerals. If I look at the next one, a polyatomic ion is at the beginning, so I'm going to name it just like it is again, so this will be ammonium. Again, it doesn't need a Roman numeral. Since the second element is single, then it's going to act it needs to be treated just like a single element in all ionic compounds and be ending in the IDE, so this will be chloride. Our next one has two polyatomic ions, so again, you simply write both polyatomic ions. So you've got your ammonium for your NH4, your SO4 is sulfate, so this will be ammonium sulfate. If you look at this next one, we have copper as our first element. Does it need a Roman numeral? Well, yes, because it's not in the first two columns or silver, cadmium, zinc, or aluminum. And then our CO3 is a polyatomic ion that is called carbonate. So you look up the charge of the carbonate, it's -2. Since this is -2 and I only have one of them, then that means the copper has to be +2 to balance it out and get a 0 overall charge. So my Roman numeral here would be a 2. The last one that's on here is unique because this O2 is actually a polyatomic ion. And the only way you would know that is if you look at the charge of oxygen on the table. Normally it's -2. And if you multiply this by 2, that would make this -4, which means that the sodium would have to be a +2 charge. Sodium is always a +1 charge because it's in the first column. So if oxygen in this case has a -1 charge, which it would, that is actually the peroxide ion. So naming this one, it's actually going to be sodium and then peroxide. So if you have an O2 as the second part, check to see what charge the oxygen would have based on whatever you have at the beginning.